Hello friends, let us explore the groundbreaking new theory that challenges the Big Bang and inflation. In this video, we will delve into the revolutionary model of the universe's origin, proposing a cosmos born from a different kind of singularity. We break down the problems with the prevailing inflation theory and introduce a compelling alternative that could rewrite the history of everything. Let's go! Hello everyone and welcome back to the channel. Today we are going to embark on a journey that might just turn your understanding of the cosmos on its head. For decades, the Big Bang Theory has been the cornerstone of our understanding of the universe's origin. It's taught in schools, discussed in documentaries, and widely accepted by the scientific community. But what if I told you the Big Bang, as we understand, might be dead? That's a bold claim, I know, but a growing number of physicists and cosmologists are proposing radical new theory, challenging the very foundation of how we believe our universe began. And today we are going to explore one such theory that offers a compelling inflation-free alternative to the Big Bang. Before we dive into what's new, let us quickly recap what Big Bang Theory tells us. According to this model, our universe began approximately 13.8 billion years ago from an extremely hot, dense point, also known as singularity. From this initial singularity, the universe has rapidly expanded and cooled and eventually formed the stars, galaxies, and structures we observe today. Evidence for the Big Bang includes the expansion of the universe, the first observed by Edwin Hubble, and the cosmic microwave background, also known as CMB radiation, which is essential. It is essential part of the universe. It is the afterglow of this primordial explosion. For many years, this model provided a comprehensive framework. It explained how light elements like hydrogen and helium were formed and why the universe is expanding. It was and still is expanding, a monumental achievement of the scientific thoughts, and because of coming out with the Big Bang Theory that predominantly explained everything, mostly everything in the universe. However, as our instruments become more powerful, our theoretical understanding deepened. Certain puzzles begin to emerge within the Big Bang framework. These weren't minor discrepancies. They were fundamental challenges that for a long time left cosmologists scratching their heads. One of the most significant of these puzzles led to the development of an add-on to the Big Bang Theory, a concept called cosmic inflation. The inflationary theory was introduced in the early 1980s by physicist Alan Guth. It is an incredible, clever idea designed to solve some of the biggest problems with the standard Big Bang model. What problems, you may ask? Well, there are three main problems, starting with the flatness problem, the horizon problem, and the monopole problem. Now let's break them down one by one. First, the flatness problem. Our universe appears remarkably flat. Not flat like a pancake, but in terms of its geometry. Imagine trying to draw a giant triangle across the universe. Some of its angle would be very close to 180 degrees, just like a flat piece of paper. The Big Bang alone does not naturally explain this extreme flatness. Second, the horizon problem. The cosmic microwave background radiation is incredibly uniform in temperatures across the entire sky. This is strange because of the regions of the universe that are far apart and were never in casual contact in standard Big Bang model somehow have the same temperature. How do these areas of the universe communicate or maintain equilibrium with each other? That's a mystery. And the third, the monopole problem. Certain grand unified theories predict the existence of exotic particles called magnetic monopoles that should have been produced in abundance during the early universe, yet we have never observed a single one of them in our universe. So inflation theory solves all of these issues by proposing an extremely rapid exponential expansion of the universe in the first tiny fraction of a second after the Big Bang. This super fast stretch smooths out the universe, which solves the flatness, bring distant region into casual contact that solves the horizon issue, and dilutes any monopoles to an unobservable density, which also solves the monopoles. It sounds like a perfect solution, right? And for many years, it was widely accepted. But here is the kicker. We have no direct observational evidence for the inflation itself. It's a theoretical patch, a brilliant one, but still a patch. And some physicists are beginning to feel that these patches or this solution is becoming more complex and less elegant than the universe itself is trying to describe the problem. What if there is a simpler, more fundamental explanation? The lack of direct evidence for inflation has led to fascinating debate. Critics argue that the inflation can predict almost anything, making it difficult to falsify, which is a core tenet of the scientific theory. It is so flexible that it might not be truly predictive. This skepticism isn't about dismissing the incredible success of the Big Bang model or the ingenious nature of the inflation. It is about pushing the boundaries of our understanding, questioning the assumptions, and seeking a deeper, more elegant truth. As Albert Einstein famously said, the most incomprehensible thing about the universe is that it is comprehensible. This intellectual restlessness has paved the way for the entire new theoretical framework, brave enough to discard the inflation, even rethink the Big Bang singularity. Today we are going to focus on a particular class of these theories that offer a compelling vision of the universe without a beginning, or at least without the kind of Big Bang beginning that we have been told about for almost 60-70 years. These alternative models have often proposed that the universe either never began the traditional sense, or that the beginning was not an expansion from a singularity, but rather a phase in the large, cyclic, or eternal cosmic drama. Think about it. If the universe is truly infinite in time, the problem that the inflation tries to solve might simply vanish. No need for a super fast stretch to smooth things out if the universe has always been smoothing itself out, or if it emerged from a state that was already smooth. No need to explain why distant regions were in contact if they were always been part of the same large interacting system. This is where the landscape of the modern cosmology gets truly exciting. It's a call to re-examine our most fundamental assumption and perhaps step into an entirely new paradigm. So what does a universe without inflation and without the traditional Big Bang look like? Let us explore one fascinating example. A type of cyclic universe theory, sometimes referred to in a various form, but for our purpose, let's call it the Phoenix universe, a universe that repeatedly rises from its own ashes. Imagine, instead of a singular explosive beginning, a universe that undergoes cycles of contraction and expansion instead of a big bang. We have big bounce, actually, to explain in a different way. In these models, our current expanding universe is just one phase in an eternal cycle. Before our expansion, the universe was contracting, squeezing down to an incredibly dense but not necessarily singular state. This dense state when bounces back out, initiating a new period of expansion. This concept is often rooted in theories like loop quantum gravity or string theory, which tries to unify quantum mechanics with general relativity. This theory suggests that the space and time themselves might be quantized, meaning they aren't infinitely divisible. This graininess of the space-time could prevent a true singularity from ever forming. Instead, universe would reach a minimum size and then rebound. Now, how does a Phoenix universe solve the problem that inflation was designed to fix, but without the inflation? The flatness problem can be addressed because our endless cycle, the universe naturally evolves towards the flatness. If it contracts and expands over and over, any initial curvature would be ironed out, much like how stretching a crumpled sheet of paper flattens out. The horizon problem is also beautifully resolved. If the universe has existed eternally, undergoing these cycles, then all regions of the universe have had infinite time to be in casual contact. There is no need for a sudden inflationary burst to make everything uniform. It's a simple natural consequence of its eternal nature. And what about the monopole problem? In a bouncing universe, any magnetic monopoles created during a previous cycle could simply be diluted and scattered into such low densities that they become virtually undetectable. Or perhaps the conditions in these cyclic models don't favor their creation in the first place. But the elegance doesn't stop there. Some of these theories also have intriguing explanations for dark matter and dark energy, the mysterious component that make up most of our universe and drives it accelerating expansion. Perhaps these are not separate exotic particles or forces, but inherent properties of relics of those cosmic cycles. While still under active development and highly theoretical, the Phoenix universe presents a compelling inflation-free narrative for the cosmos. It suggests a universe that is endlessly recycling, endlessly renewing, and eternally alive. It removes the need for a singular, inexplicable beginning and replaces with a grand, continuous cosmic drama. Of course, these theories have their own challenges. For instance, explaining why the universe bounces instead of collapsing into a true singularity, or precisely how information survived the bounce are still areas of intense research. But the very fact is that they were rigorously exploring these alternatives is a testament of the dynamic nature of science. So where does this leave us? Is the Big Bang truly dead? Perhaps a better way to put it is that our understanding of the Big Bang is evolving. The core observation, the expanding universe, and the CMBs remain valid, but the interpretation of what caused the expansion and what came before is wide open for revolutionary new ideas. The scientific method thriving on challenging existing paradigm, it through its rigorous process of questioning, theorizing, the testing that we push the boundaries of human knowledge, the shift from geocentric to heliocentric universe, or from Newtonian to Einsteinian physics, show us that what is considered fundamental truth can and often does change. The next generation of telescopes and experiments like James Webb Space Telescope or future gravitational wave observation could provide crucial data and new theories. They might detect subtle signatures that point towards cyclic universe, or perhaps reveal entirely new phenomena that we haven't conceived yet. The beauty of science is its consistent quest for deeper understanding. We are living in an incredible era where most fundamental questions about our existence, that is, where did we come from, what is the nature of reality, are being tackled and unprecedented intellectual rigor and technological prowess. Whether it is a cyclic universe, a multiverse, or something entirely different, the journey to understand the cosmos is far from over. The Big Bang Theory gave us the incredible starting point, but it's increasingly clear that the story of our universe is much richer, much more complex, and perhaps much more eternal than we imagine. So what is the next time when you look at the night sky, remember that you are not just seeing the remnant of the single explosive event. You might be gazing into a universe that has lived countless lives, a cosmic dance that has no beginning and no end. So friends, thank you for joining me on this mind-bending exploration. What do you think about the idea of universes without the inflation, or without a Big Bang, or a singularity? Do these new theories resonate with you? Let me know your thoughts in the comments below. And if you have enjoyed this video, please give it a thumbs up, share it with your friends, and subscribe to our channel for more deeper dive into the mysteries of the universe. Your support helps us continue to explore such fascinating topics. Thank you for watching me live, and I will catch you again in the next one.